Hello, that's about as good and clear as I can make it. We went over this problem today in my class, but I want to show you how to do this problem on a video so that if you weren't quite sure, you could watch it again. And I wanted to make this for the people who are absent. So we're going to look at question number 1 first. The diameter of a hydrogen nucleus, which is a single proton, is 8.4 e negative 16 meters. So I'm going to put D equals 8.4 e negative 16 meters. Now, as I have told my class, this is equivalent to saying D equals 8.4 times 10 raised to the negative 16th power meters. It's also sometimes written by computers as D equals 8.4 times 10, and then this caret negative 16, because here's the deal. Trying to get this superscript on typed documents is not particularly easy. And so this is the way that they do it. We're going to start out with the E, and I'm going to show you how that works on a TI-30X2S, which is the calculator I use most often in class. We're going to start by writing down the given with the E. These are all the same number, just different ways to write it or type it. And they're equivalent. So 8.4 e negative 16 meters, and you have to use dimensional analysis. This is chemistry. It's going to get more difficult, and we need to be able to use this dimensional analysis. And the first question I always ask is, what unit goes in the bottom, the denominator of the first fraction? It has to be a meter because we're not cross-canceling numbers, we're cross-canceling units. And I have also asked, what's the conversion for meters to centimeters? Because the question says, convert this to centimeters. And the conversion for centimeters to meters is 100 centimeters equals 1 meter. And then I always ask this question, what goes in the denominator, 100 or 1? And the answer is 1, because the number has to stick right by the unit it has. If it's meters in the bottom, it has to be 1 meter, whatever I wrote, the correct conversion. And then in the top goes 100 centimeters, and I cross-cancel the meters, and my answer is now in the units of centimeters. Now, I don't know how well this is going to work, but I'm going to put the calculator here, and I'm going to show you how to put this number into the TI-30X2S. So we're going to use 8.4, and then the E key, or the times 10 to the key, that's what E stands for, times 10 raised to the power of, and they did that all with one letter. 8.4, it's second x to the minus 1. Do you see you get a capital E, just like I wrote in the problem? You have to use this negative sign, not the minus sign, 16. And then we're multiplying it times 100. We hit equals, and we get 8.4. And see, it says times 10 to the negative 14th down there. And I'm going to write this answer. The answer is 8.4 times 10 to the negative 14th centimeters, and you box your answer with units. That's the answer to number 1. Let's look at the answer to number 2. Number 2 says I have a width, and we could talk about width versus diameter, they're honestly the same thing, of 1.06 e negative 8 centimeters. And it asked me to convert this to meters. Well, guess what? I'm going to start the same way. 1.06 e negative 8 centimeters. And I'm going to put that fraction, centimeters has to go in the bottom, and I'm going to use this same conversion from up here, but this time the 100 goes in the denominator because it sticks to the centimeters. 100 centimeters equals 1 meter. It's an equivalency. Now what I'm going to put into my calculator is 1.06 e negative 8 divided by 100. And the answer to this, I will do it right here. 1.06 second e, which is second x to the minus 1, negative 8 divided by 100 equals 1.06 e to the negative 10th. I'm just going to use that shorthand. You can write times 10 to that. Either one is correct. They are equivalent, and that's going to be meters. Box my answer with units. Now we're gonna look at number 3. How many times larger is a hydrogen atom than its nucleus? I'm gonna go through this one really quick, then I'll do number 4, and I'll probably stop the video and make this into 2 videos. If I said to you, there's line A and here's line B, how many times bigger is line A than line B? You can see that I've drawn that A, sorry, let's cross that out. A is about 2 times B in height. So we're doing the same thing. If I told you that this was 100 centimeters and this was 50 centimeters, I hope it's obvious to you that to get how many times larger, I take 100 divided by 50. And there's no unit on this answer. The centimeters cancel out both ways, and it's 2 times larger. Okay? Now we're gonna do this for the one that we just did. We have to use the same units. I've got meters here, and I've got meters down here, or I've got centimeters here and centimeters there. It doesn't matter which one you use. You just have to use centimeters and centimeters because they have to cancel out. So I'm going to use centimeters and centimeters. There's one, there's the other. And guess what? The entire hydrogen atom is bigger than the nucleus. Remember, a negative exponent, the bigger the negative exponent is, the smaller the number. So I have 1.06 E negative 8 centimeters divided by 8.4 E negative 14 centimeters. Centimeters cross out, and now I'm going to put this in my calculator. 1.06 second x to the minus 1 on this calculator, but you're looking for the E or the EE, negative 8 divided by 8.4 E to the negative 14th, and I hit equals, and I get this long answer, and it is 126,190.4762. How many significant digits are in this? 3, right? How many significant digits are in this? 2. I can only use the least number of significant digits that I have. So I have to make this 2 significant digits. So here's what I did. I go to the 2, I look across the fence. This is how I always say it. If this is 5 or higher, this goes up, and it should be 1, 3, and then I have to have the same number before the decimal point of zeros. Doesn't this have 1, 2, 3, 4 zeros? The 2 rounded up to 3, and then I have, this is 126,190, and now I have 130,000. Isn't that 2 significant digits as long as I don't put the decimal in it? I'm going to pause this video. That is the answer to 1, 2, and 3, and then I'm going to do number 4 on a separate video.